All right, hey everybody, welcome back to probability practice. We're going to be now doing prompt number 2, so let's get straight into it. I'll put the prompt right here. Okay, so the prompt is: a validation study is to be performed in a local hospital to check the accuracy of assessment of hospital-acquired infection, INF, following coronary bypass surgery, also known as CABG. In a given year, the hospital performs 1,100 CABG procedures. The CDC algorithm currently used to categorize subjects as having INF. We are trying to validate this algorithm. And in this algorithm, all CDC plus subjects, CDC positive subjects, with the N being 100, and a random sample of CDC negative subjects, with the N being 1,000, will be ascertained by an infectious disease fellow. All right. Assuming that the ID fellow's determination is correct, suppose 100 of the CDC positive subjects are ascertained, of whom the ID fellow confirms 80. Okay? And because there's a large number of CDC negative subjects, which we just said is 1,000, only a sample of 100 is studied. So we're just going to be taking 100 of that 1,000, of whom the ID fellow confirms 90. Okay. And only use the two samples of 100 as your study groups. Okay. And think about using a 2x2 table to organize disease status and test result, as well as true, false, positive, and negatives. Okay. Lots to unpack there, so let's go ahead and put it on the board and visualize it to make it a little bit easier. So let's go ahead and start with our test. Okay. So our CDC positive, and we have CDC negative. Okay, so our test. So CDC positive. Okay, which we can call test positive, and our CDC negative, which we can call our test negative. Okay, so that's what we have here. Okay, and then we have our ID fellow confirming these tests. So we have our ID fellow, which we can call our D positive, disease positive, ID fellow positive, ID fellow negative, D negative. Okay. There we go. So we have our 2x2 table now, and let's put our totals here. Okay, now much easier to visualize. So we know that out of our two samples that we're taking a look at, we're using both of the samples equaling 100 each. Okay, so we're taking 100 of the CDC positive, total here, and 100 of the CDC negative, so total here. All right. And of which they say the 100 of the CDC positive, the ID fellow confirms 80. So he confirms that 80 out of these 100 are true. He confirms them to be true. And remember earlier we're saying that we're assuming that the ID fellow's determination is correct. So the gold standard and end all be all. All right. So he confirms that out of the 100, 80 of those are true. So they test positive and they are positive. Confirm true. So that leaves us here with 20. And then out of the CDC negative subjects, out of that 100, we confirm 90. So that means they test negative. Okay, we're confirming that they test negative and they are negative. So those 90 of those are true. True negatives, and which we'll get to that in a second, the true negatives and true positives. And so that leaves us, out of that 100, there's 10 left over here. Okay, and before we move on to the questions at hand, let's go ahead and identify these, because it will help us a lot later, our true, false, positive, and negatives. So our true positives, let's start there. Our true positive means that they test positive and they are positive. That's a true positive, okay? So true positive, okay? And then let's go to our true negatives. Our true negatives are those that test negative and are negative, okay? Our true negatives. True negative. Okay. So what does that make these two left over here? That means if they test negative but really are positive, they're disease positive but they test negative, that would make them a false negative, okay? False negative, okay? Because they tested negative but really they were positive. Okay, so what is left here? Intuitively, we would know that this is a false positive. Okay, why is that? Because they were disease negative, but they tested positive. Okay, so this is a good place to go ahead and start answering our prompt. We've got all the information that we need, right? So let's go ahead and answer the first part of the question, which is, what is the PV plus of the CDC algorithm? So PV plus being our positive predictive value, okay? Part A is, what is our positive predictive value? Okay, so when we are thinking of our positive predictive value, what we're really concerned with is, out of all of the positive tests, okay, how many of those were true positives, okay? So let's go ahead and, or the probability of, another way to say that is the probability of the disease is positive, right? How many are truly positive, given that T positive, okay? Given that T positive. So assuming that test positive occurs, how many of those are truly positive? So how do we find that in simpler terms? Okay, we're looking for true positives, total outcome of true positives over the total amount of positives, total possible outcomes of positive. So what does that equal? So we have our true positives, right? So it is over our true positives plus what? What else tested positive? Our false positives. That includes our false positives. False positives, okay? And so let's go ahead and plug in our numbers here. So true positives is equal to 80, okay? Over our true positive plus our false positive. So what does that equal? 80 plus 20, or plus 20. And so that is 80 over 100. I'm not going to write that down for you. So 80 over 100, that is 0.8. It's equal to 0.8 or 80%. All right, let's go ahead and do part B. Part B asks us, what is our PV negative? Our negative predictive value, okay? Conversely, move this down a little bit more. Just move this down a little bit more. Give us some space. Okay, conversely, right? We're concerned with the probability, right? The disease negative, right? That we don't have the disease, right? Given that, test negative, our test negative. So given that our test is negative, right? What's the probability that we truly are negative, that the person that we're testing is truly negative, okay? So let's go ahead and apply the same theory, okay? We want to find all of the true negatives out of all of those who tested negative. So who tested negative, right? Who tested negative are true negatives, right? And our false negatives plus false negatives, okay? Let's go ahead and plug in our numbers here and let's see what we get, okay? Our true negative is 90 plus our true negative plus our false negative, which is 10. And to save us some time, that is 90%, okay? 90 over 100, so 90%. So given that our test is positive, okay, we correctly tested, or the probability of you being truly negative is 90%, okay? Let's do part C here. We'll do this one in black, okay? C. And C is asking for, what is the sensitivity of the CDC algorithm? Okay, so what is the sensitivities? We're asking for sensitivity. Did I spell that right? We'll find out. Okay, sensitivity, yeah. Probably the sensitivity. So with sensitivity, what we're concerned with is, what is the probability, okay, probability, right, that we test positive, right, given that the disease is positive. Okay, given that the disease is positive. So sensitivity is, out of all of those who are disease positive, what is the probability that we that we test correctly for those who are positive? What's the probability that we test correctly for those that are positive? Okay, so when we're doing that, we want to look at all of those who are T positive or true positive, right? Over all of those who are true positives, all of those that are actually disease positive, okay? So out of all of those that are disease positive, right, what's the probability that we test them correctly? So that's true positive plus our false negative, okay? Because our false negative, right, is really disease positive plus false negative, okay? So let's go ahead and plug in numbers here, all right? So true positive is 80 over, right, our true positive plus our false negative. So that's 90, okay? Saving some time here for us. And let's go ahead and do this on the calculator live for you so that you can see 80 over 90, right? We get 0.88 all the way to 9, right? And we'll just round that up to 2 decimal points. So that's 0.89, 89%. Okay? So out of all of those that are truly disease positive, we tested correctly for them 89% of the time. All right. Last part here, okay? And I'm going to do this over here on the left-hand side. Just running out of space down there. What is the specificity? Part D. Specificity. Okay, I'm going to spell it right. We'll find out. Okay, can you see that? I don't think you can see that. So let's go ahead and we'll go back to dark green here, or we'll make it red. Okay, specificity. Okay. So what we're worried about, concerned with specificity, okay, is what is the probability, okay, okay, that we are disease negative, okay, disease negative, right? Given that we test negative, okay, so specificity, okay, we're worried with that. If we test negative, right, what is the probability that we are actually negative, given that we test negative, okay? So what are we looking for is how many total T negatives do we have? We have 100 T negatives, okay? So we're looking for true negatives. What is the probability that we're really truly negative? So true negatives, where are true negatives? Over here, okay? So true negatives. Okay, looking at the prompt, specificity, okay? Over all of those who are true negatives and false positives. Now, why is that? Because we're looking at all of those. Where's false positive? This side, right? Okay. True negative plus our false positive. So false positive. All right. Equal sign. So take a second to think about why this is. Okay. And we'll go ahead and plug in our numbers here. Okay. True negative, false positive. Yep. Okay. So let's plug in our numbers. 90 over our true negative, which is 90, plus our false positive, 20. Okay, so this is 90 over 110. What is this equal to? Let's take a look, okay? 90 over 110, 0.8181. We'll go to 2 decimal points right here. 0.82 or 82%. All right. So there we are. There we have it, okay? Our positive predictive value, our negative predictive value, sensitivity, okay, and specificity. So when you put it into a table like this and label your false positives and negatives, okay, it's a lot easier to rationalize why we are looking for what we're looking for. All right, thanks guys for tuning in to part 2 of probability practice. Hope you enjoyed it. Thanks.